Hello everyone. Today we'll be solving EDEXCEL International IGCSE 91 Chemistry Paper 1CR Jan 2022. Today we'll be solving question number 9 to question number 11. This is the part 3 of the video. If you have missed the part 1 and part 2, then you can find it in the playlist. Question number 9. A student is given a mixture of two white solid compounds and colorless solution containing the same two compounds. The student is told that one of the compound is a halide and the other compound is a carbonate. Give two reasons why the student should know without doing any test that one of the compound cannot be copper 2 carbonate. Copper 2 carbonate is insoluble. So that's one thing. Second thing is, copper 2 carbonate is green in color. It cannot be colorless solution. Part B. Describe tests the student could do to show the mixture contains potassium carbonate and potassium iodide. So basically, first of all, the student can perform a flame test. When the student perform a flame test, lilac flame will indicate the presence of potassium ion. And after that, the student can add an acid to the mixture of solid or the solution. If it produces gas, then the gas can be passed through lime water, and if the lime water goes cloudy, which means that there is carbonate. And to test for iodide, the student can add dilute nitric acid followed by silver nitrate, and a yellow precipitate will indicate presence of iodide. Question number 10. A student is given a pure sample of sodium carbonate crystal and it's told that the formula of the crystal is Na2CO3.XH2O. State what X in the formula shows about the sodium carbonate crystal. The XH2O indicates that there is water of crystallization and this particular salt is hydrated. Part B. The student uses this apparatus to find the value of X in sodium carbonate.XH2O. We can see crucible, we can see sodium carbonate crystals, and heat applied. This is the student's method. Find the mass of an empty crucible without a lid. Add some sodium carbonate crystals Na2CO3.XH2O to the crucible. Find the total mass of the crucible and sodium carbonate crystals. Heat the crucible to remove water from the crystals. Allow the crucible and the contents to cool down. Find the mass of the cold crucible and contents. These are the student's results. Empty crucible, mass is 22.75. Crucible and sodium carbonate crystal.XH2O, 29.71. Cold crucible and contents, 25.93. Calculate the mass of sodium carbonate left after heating and cooling. So to find out the mass of sodium carbonate left after heating and then cooling, all right, we'll have to consider the mass of empty crucible and we'll have to consider the mass of cold crucible and content. So 25.93 minus 22.75. And when we do the subtraction, it comes 3.18. The next question, calculating the mass of water lost from the sodium carbonate crystals during heating. Now, to find out that what mass of water is lost, we can do something like this. First of all, we know that the mass of sodium carbonate .xh2o along with the crucible is 29.71, and the mass of cold crucible and the content is 25.93. So whatever is lost, it should be, all right, it should be so whatever is lost, it should be water. So 29.71 minus 25.93. So this is equals to 3.78 grams. Now the question says, show that the student's results suggest that the formula of the sodium carbonate crystal is Na2CO3.7H2O. We are given, MR of Na2CO3 is already given, MR of H2O is already given. So first of all, we need to calculate the number of moles of sodium carbonate. So number of moles of sodium carbonate, Na2CO3, all right? So 3.18 was the mass of sodium carbonate, MR is 106. We divide and we get 0.03 moles. Then we need to find out the number of moles for water. So we have the amount of water 3.78 gram, and we know amount of water is 18. We divide it and we get 0.21. Now it's time for the ratio. So we can already say, in order to obtain a ratio in between these two, so number of moles of Na2CO3 ratio with number of moles of H2O. All right. So 0.03 is to 0.21. We need to divide everything by the smallest number in order to fulfill the ratio. So that gives us 1 is to 7. Part C. The student's teacher says that the correct formula of the sodium carbonate crystal is Na2CO3.10H2O. The student did not make any mistake in their measurements. Explain what could have caused the student's value for X to be too low. The student's teacher says that the correct formula of the sodium carbonate is Na2CO3.10H2O. That means there is more water in this particular sodium carbonate which the student couldn't account for. Now, the student did not make any mistake in their measurements. So there is no experimental error in terms of measuring those, taking the mass of the crucible and then, all of those. Explain what could have caused the student's value for X to be too low. So maybe not all of the water were able to evaporate. So the crystals were not heated for long enough, all right, and all of the water were not evaporated. Part 2. Describe how the student could improve the method to obtain a more accurate value for X. So the student can repeat the heating and the cooling process until the solid comes to a constant mass. Question number 11. A student investigate the temperature changes during the reaction between zinc metal and copper to sulfur solution. The student considered two different methods. In method number 1, the student uses a polystyrene cup and pours 50 cm cube of copper to sulfur solution into the polystyrene cup, records the temperature of the solution, and then adds 3 grams of zinc powder. So zinc is more reactive, so it will just simply displace the copper. This is an exothermic reaction. Start using the thermometer and record the highest temperature reached. In the second method, the student uses a rubber bung, a glass bottle, records the temperature of the 50 cm cube copper to sulfur solution, pours the 50 cm cube copper to sulfur solution into the glass bottle, adds 3 grams of zinc powder, push the bung and the thermometer into the bottle, record the highest temperature reached. So, from looking into this particular experiment, in the polystyrene cup experiment, we required a lead, which would make it more accurate because the lead would prevent any heat loss. And looking into this glass bottle, there is a problem. The problem is glass bottle conducts heat really well. So it will just give off the heat to the surroundings. Now the question is, discuss the advantage and disadvantages of each method. When questions like this appear, all right, then we must write for both sides. So first of all, method one, the polystyrene cup prevents heat loss to atmosphere. However, we already told you that as I have already told you, there is no lead, so heat energy is lost to the atmosphere. As the heat energy is lost in the form of evaporation of the water, it can be those forms. Styrene will ensure even temperature, and it will give a highest accurate temperature. All right. However, there is no lead, so there is a possibility of spillage. Polystyrene cup container thermometer, can be very unstable. It can easily tip over. All right. In method two, the glass bottle is a poor insulator of heat. Thermal energy is lost, and the bung helps reduce, thermal energy loss. However, the bunk, with the bunk there is no spillage. All right, but there is a problem. It cannot stir the solution, so cannot ensure even temperature and even heat distribution within that particular vessel. Question number 11b. The equation for the reaction is zinc. When it reacts with copper to sulfate, it produces zinc sulfate and produces copper. 50 cm cube of copper to sulfate solution contains 0.025 moles of copper sulfate. A mass of 3 grams of zinc is used. Show that the zinc is in excess. In order to show the zinc is in excess, we must understand that 1 mole of zinc reacts with 1 mole of copper sulfate. So to demonstrate that particular point, 0.025 moles of CuSO4 reacts with 0.025 mole zinc. So the mass of zinc needed, mass of Zn needed will be 0.025 mole multiplied by 65, giving 1.625 grams. And we can definitely say that 3 grams is greater than 1.625 grams. Part C. The student reacts a solution containing 0.025 moles of copper sulfate with an excess of zinc. These are the student's result. Temperature 50 cm cube of copper to sulfate solution, 21.1 degrees Celsius. All right. Highest temperature reached is 40.6. Show that the energy change Q for this reaction is 4000. Mass of 1 cm cube solution 1 gram. The solution has 4.2 joules per gram. Joules per gram per degree Celsius. Specific heat capacity. So in this kind of calculation, first of all, we will have to show temperature rise. So we know Q is equals to mc del T. So the mass here, because we have 50 cm cube of copper to sulfate, so the mass will be 50. Specific heat capacity is 4.2, and the temperature change is 40.6 minus 21.1. By factoring out everything, we get 4,100 joules. So the question says that show, and we have shown it. Next question. Part 2. Calculate the molar enthalpy change del H in kilojoule per mole for this reaction. So we can say that 0.025 moles of CuSO4 is producing 4,100 joules. Now we need to calculate it in kilojoules. So 4,100 divided by 1,000, and whatever the answer comes, kilojoules. So 1 mole of CuSO4 will produce 4.1 divided by 4.1 kilojoule divided by 0.025 moles. So the answer is, since the energy is released, so this is an exothermic reaction, so negative sign has to be used. So the energy comes out to be 164 kilojoule. Part D. The ionic equation for the reaction is zinc plus Cu2 plus Zn2 plus Cu. Explain what is oxidized and what is reduced in this reaction. So we can easily say that in this reaction, zinc goes from oxidation state of 0 to oxidation state of +2, that is oxidized, and Cu2 plus goes from Cu2 plus, which is +2 oxidation state, to 0, that is reduction. And the question says explain what is oxidized and what is reduced in this reaction. So we can say that zinc is oxidized because it loses electron. Then we're going to say that copper 2 plus ions, so the copper ions is reduced because it gains electron. Guys, thank you for joining the video today. And we upload videos like this every week. So if you have any question paper that you want us to solve related to chemistry and biology, you can upload it. And subscribe to our channel so that our channel grows, and we will be uploading videos like this. You can press the bell icon so that basically you do not miss any videos when they're uploaded. You are the first one to see. Bye bye.